Hello and greetings to everyone. We have the following questions to answer. Question 1. Given the sets, we have the universal set with elements 0, 1, 2, 3, right up to 14, 15. We have the set E with elements 0, 2, 4, 6, 8, 10, 12. We have the next set B with elements 0, 1, 2, 3, 4, 5, 6. And we have the set C with elements 0, 11, 12, 13, 14. Fine. For question A, we have A intersection B. For us to find A intersection B, that means we need the elements that we can see in the set A and in the set B. We are going to write down those elements. Let's take down solution. We are going to start by writing down the sets. First, we have the universal set. This is how we denote the universal set. It has elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 is the last element. We have the set E, which has elements 0, 2, 4, 6, 8, 10, 12. We have the set B, which has elements 0, 1, 2, 3, 4, 5, 6. And lastly, we have the set C, which has elements 0, 11, 12, 13, 14. For question A, we have to write out the elements of the set E intersection B. That means the elements we can see in the set A and in the set B. We can see 0 here. You can see 0 here. So 0 is an element of E intersection B. You can see 2, 2. The next we can see 4, 4. Next we can see 6, 6. E intersection B has elements 0, 2, 4, 6. We go now to question B. We have to write the elements of the set E intersection C. That means the elements you can see in the set A and in the set C. You can see 0, 0. Next we can see 12, 12. So these are the elements of the set E intersection C. Next we go now to question C. We have to write the elements of the set B intersection C. That means the elements we can see in the sets B and C. Looking at these two sets, the only element we can see which is common in the two sets is 0. B intersection C is simply equal to 0. We go now to D. Question D, we have to write the elements of E intersection B intersection C. That means the elements we can see in these three sets. Looking at the three sets, the only element we can see in the three sets, we can see only 0. There is no other element we can see which is common in the three sets. Therefore, E intersection B intersection C is simply equal to the singleton 0. This set is a singleton because it has just one element. We go now to E. We have to write out the elements of A union B. That means the elements in the set A or the set B. So what we are simply going to do is we are going to write out all the elements in the set A or the elements in the set B. So we are going to write them in ascending order. That it means from the smallest to the biggest. We have 0, 1, 2, 3, 4, 5, 6. 0 is already here. 2 is already here, 6 is already here. Now we need to include 8. Next will be 10, and lastly 12. So these are the elements of the set A union B. Next, we go now to F. We have to write the elements of the set B union C. That means we have to write the elements of the set B or the elements of the set C. So we are going to start with 0. Next will be 1. We go to 2. We must separate the elements by making use of a comma. We go now to 3. We go to 4. We go to 5. We go to 6. If you go now to the set C, 0 is already here. Just start from 11, 12, 13, lastly 14. So these are the elements of the set B or C. We go now to G. We have to write the elements of A union B union C. That means the elements of A or B or C. You're going to write them in ascending order. You're going to write out all the elements of the sets A, B, C. We have 0, 1, 2, 3, 4, 5, 6. Next, there is no 7, there is 8, there is no 9, there is 10, there is 11, there is 12, there is 13, and lastly 14. So these are the elements of the set A union B union C. We go now to H. We have to write out the elements of the set A complement. The elements of the set A complements, they are simply those elements of the universal set which are not elements of the set A. So we are simply going to write down those elements which are elements of the universal set but are not found in the set A. We have 0 in the set A. There is no 1, so we are going to write down 1. There is 2 in the set A. There is no 3, we are going to write down 3. 4. There is no 5, we write 5. 6. There is no 7, we write 7. 8. There is no 9, we write 9. There is 10. There is no 11, we write 11. There is 12. There is no 13. There is no 14. There is no 15. So this is the set A complement. We go now to I. We have to write the elements of B complement. When you see B raised to the power C as such, that means you have to write the complementary set of the set B. We can also denote it as such, so you should not be confused with this. It is another way of representing the complementary set. So in this case, we are going to write out all the elements of the universal set which are not found in the set B. So we have 0, 1, 2, 3, 4, 5, 6. We have to start from 7, 8, 9, 10, 11, 12, 13, 14. We end at 15. We go now to J. We have to write C complement. That is the elements of the universal set which are not found in the set C. We have 0 in the set C. There is no 1. There is no 2. There is no 3. There is no 4. There is no 5. There is no 6. There is no 7. There is no 8. There is no 9. There is no 10. There is 11. There is 12. There is 13. There is 14. There is no 15. So this is C complement. We go now to question K. We have to write A complement union B complement. This will simply be equal to, we are going to copy the elements of A complement with the elements of B complement. So this will simply be equal to, we have 1, 3, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is A complement union B complement. Now we go to L. For L, we have to write A intersection B complement. That means we are going to write out all those elements which are elements of the universal set but are not elements of A intersection B. This is A intersection B. We have 0, 2, 4, 6. So we don't have the element 1. We don't have the element 3. We don't have the element 5. We don't have the element 7. We don't have the element 8. We don't have 9. We don't have 10, 11, 12, 13, 14, and lastly 15. We go now to the next question, question M. We need A complement union B complement union C complement. This will simply be equal to, we are going to copy the elements of these three sets, 1, 2, 3. This will give us 1. We are going to write them in ascending order, 2, 3, 4, 5, 6, 7, 8. We have 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The only element which is absent is 0, which is found in the intersection of the three sets. We go now to N. For N, we have to write the elements of A intersection B intersection C complement. That means we have to write out those elements which are not found in the intersection of three sets. We know the intersection of the three sets is simply the element 0. So from 0, we have 1. 1 is not found here. We have 2, we have 3, we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. At this stage, you'll be able to see that A complement union B complement union C complement is the same as A intersection B intersection C complement. At higher levels, you will see this. So you take note of it. We move now to the next question. O. Question O, we have to write the cardinality of the set A union B. That means we have to count the number of elements in the set A union B. So let's look at the set A union B. This is the set A union B. We are going to count the number of elements in this set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 elements. The answer in this case will simply be equal to 10. You take note, it is not a set. If you write something as such, it is wrong. It is not a set. We go now to question P. For question P, we have to write the cardinality of the complementary set of A union the complementary set of B. This will simply be equal to, let's look at the set of A complement union B complement. Let's count the number of elements in that set. This is a set A complement union B complement. We are going to count the number of elements in this set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The answer is simply 12. We go now to question Q. For question Q, it says that we should draw a Venn diagram to represent the sets A, B, C, and the universal set. Let's do a representation of it. We are going to indicate this is our universal set. We have to draw the three sets. Draw circles. This is the set E. This is the set B. And this is the set C. We know the intersection of the three sets is simply 0. Next, we know A intersection B. For A intersection B, we have 0, we have 2, we have 4 and 6. So 0 is already here. We are going to write 2, 4, and lastly 6. The next for B intersection C. B intersection C, we have just 0. 0 is already here. This other space will be left empty. Next, we have for E intersection C, we have 0 and 12. 0 is already here. And we are going to write 12 here. Next, we are going to write out the elements of the set E. The set E has elements 0, 2, 4, 6, 8. We are going to put the 8 here. 10. We are going to write the 10 here. 12. If the set E is complete, we have 0, 2, 4, 6, 8, 10, 12. Next, now we go to the set B. The set B has elements 0, 1. We are going to put the 1 here. 2, 3. We're going to write the 3 here. 4, 5. We're going to put the 5 out here. And lastly 6. So the set B has elements 0, 1, 2, 3, 4, 5, 6. Next, now we need to represent the elements of the set C. We have 0, 11, 12, 13, and 14. C has elements 0, 11, 12, 13, 14. Next, now we are going to write all the other elements which are neither elements of the set A, nor the set B, nor the set C. We are going to write them out here. We have 0, 1, 2, 3, 4, 5, 6. There is no 7. We are going to put 7 here. 8. There is no 9. We are going to put 9 here. 10, 11, 12, 13, 14. There is no 15. We are going to write 15 here. So if you take the intersection of the complementary sets of A, B, and C as such, A complement intersection B complement intersection C complement is simply equal to 7, 9, and 15. And look at these complementary sets. You'll see the elements which are common. You can see there is 7, there is 9, there is 15. We are done with question 1. We move now to question 2. Let's look at question 2. For question 2, we have this Venn diagram. This is the universal set, because the Venn diagram represents the number of times a patient ate fish, the set F, vegetables, the set V, and meat, the set M, in the month of July. Given that when you see this N, that means the cardinality, the number of times the patient ate fish and meat and vegetable is equal to 3, and the number of times the patient ate fish or meat or vegetable is equal to 27. Question A says we should find the values of x and y. Let's answer the question. First, we know that the number of times that the patient ate fish and meat and vegetable is equal to 3, and the number of times the patient ate the fish or meat or vegetable is equal to 27. Looking at our universal set, you see that where the three sets intersect for fish, vegetable, and meat, we have x plus 2. That means the number of times the patient ate fish and vegetable and meat simply equal to x plus 2. From here, we can easily find the value of x. You know, cardinality of F and M and V is equal to x plus 2. That is, it simply means x plus 2 is equal to 3. From here, we can easily find the value of x. This will give us x to be equal to 3 minus 2, which x will simply be equal to 1. So if you replace x here with 1, 1 plus 2 gives you 3, which is true. Next, now, we have been told that the number of times the patient eats fish or meat or vegetable is equal to 27. Simply means if we sum all what we have in the sets F, V, M, it should be equal to 27. That means 7 minus x plus y plus x plus 2 plus 5 plus 10 minus y plus 2y minus x plus y minus 2 should be equal to 27. Let's do it. We have N of F and union M union V is equal to 27. That is, take 7 minus x plus y plus x plus 2 plus 5 plus 10 minus y plus 2y minus x plus y minus 2, it should be equal to 27. We know the value of x. X is 1. So we are simply going to replace x here. This will give us 7 minus 1 plus y plus 1 plus 2 plus 5 plus 10 minus y plus 2y minus 1 plus y minus 2 is equal to 27. 7 minus 1 gives us 6 plus y plus 1 plus 2 gives us 3. 3 plus 5 gives us 8. 8 plus 10 gives us 18 minus we have here negative y plus 2y gives us plus y. Here we have minus 1 plus y, so minus 1 here plus y minus 2 is equal to 27. This will give us 6 plus 18. 6 plus 18 gives us 24. 24 minus 1 gives us 23. 23 minus 2 gives us 21. Y plus y gives us 2y plus y gives us 3y. This will give us 21 plus 3y is equal to 27. Next, we are going to make 3y the surrogate formula. 3y will simply be equal to 27 minus 21. And 21 crosses the equality sign, it becomes negative. This will give us 3y to be equal to 27 minus 21 gives us 6. For us to get the value of y, we are going to divide both sides by 3. This will give us y equal to 2. Now we can conclude. Therefore, x is equal to 1 and y is equal to 2. We underline the values of x and y. Question B says, using the values of x and y, copy and complete the Venn diagram. Using the values of x and y, copy and complete the Venn diagram. Answer B. Draw the Venn diagram. This is our universal set. For fish, vegetable, and here we have meat. Here we know it is 7 minus x. We know the value for x is 1, so 7 minus 1 gives us 6. Here it is simply y. The value of y is 2. Here we have 2. Here we know it is 10 minus y. 10 minus 2 gives us 8. Here we know it is x plus 2. 1 plus 2 gives us 3. Next, here it is 5. Here it is simply 2y minus x. 2y minus x. Simplifying this will give us 2 times 2 minus 1, which is simply 4 minus 1, which is equal to 3. So here we have 3. Then here we have y minus y. No, y is simply 2. Here it is y minus 2. You know y is 2, so 2 minus 2 gives us 0. Here we have 0. And here we have a 2x plus y, which is simply equal to 2 times 1 plus 2. It gives us 2 plus 2, which is 4. And here we have 4. Now, if we sum these values, all the number of times the person has either consumed a fish, vegetable, meat, or vegetable and meat, or fish and meat, or fish and vegetable, or all the three, or none of the three, we are going to have 6 plus 2 plus 3 plus 5 plus 3 plus 8 plus 4. This will simply be equal to, 6 plus 2 gives us 8. 8 plus 3 gives us 11. 11 plus 5 gives us 16. 16 plus 3 gives us 19. 19 plus 8 gives us 27. 27 plus 4 gives us 31, which is simply equal to the number of days the month of July has. Now let's go to question C. It says from the Venn diagram, determine the number of times the patient ate. For C, question C, we have fish. So we need the number of times the patient ate fish. N of fish will simply be equal to, here this 6 simply means the number of times the patient ate fish only. We have 6 plus the number of times the patient ate fish and vegetable, which is 2, plus the number of times the patient ate fish, vegetable, and meat, which is 3, plus the number of times the patient ate fish and meat, which is 5. This will simply be equal to 6 plus 2 gives us 8. 8 plus 3 gives us 11. 11 plus 5 gives us 16. We go now to question D. Question D says we should determine the number of times the patient ate meat and vegetables. Question D, number of times the patient ate meat and vegetables will simply be equal to, from the Venn diagram, we are going to take 3 for the number of times the patient ate meat, vegetables, and fish, plus 3 for the number of times the patient ate meat and vegetables only. This will simply be equal to 6. We go now to question E. Question E says we should determine the number of times the patient ate meat and fish only. On the Venn diagram, it is simply equal to 5. For F, we have to determine the number of times the patient ate vegetables only. On the Venn diagram is simply equal to 8. And we are done with the solution of the questions.